Hi, my name is Cindy Gonzalez, and I did my sinusoidal modeling project on the London Eye. The London Eye is a revolving observation wheel or Ferris wheel in London. It has an overall height of 443 feet and a diameter of 394 feet, and it was the world's tallest Ferris wheel from 1999 to 2006. It has a total of 32 capsules for the 32 boroughs of London, and each capsule has a capacity of 25 people. One revolution takes 30 minutes, so there are only 2 revolutions per hour. I decided to make a model that gives me the height above the ground of a passenger capsule at time t. To begin, I made a diagram of the London Eye by drawing a circle and marking its overall height of 443 feet, then the diameter and radius by dividing the diameter by 2, which is 197. I found that the bottom of the Ferris wheel is 49 feet above ground by subtracting the diameter from the overall height of the Ferris wheel. I added 49 to 197 to find that the center of the Ferris wheel is 246 feet above ground. Then I added 443, the tallest point, to 49, the lowest point, and divided the outcome by 2 to find that the midline is 246 feet. Then I sketched my graph using the information I found. I labeled the x-axis time and y-axis height. Then I plotted my first point at the height of 49 feet and a time of 0. Then I plotted another point at the height of 49 feet and a time of 30 minutes, because that is the point when one full revolution occurs. Then I plotted a point at the height of 443 feet at a time of 15 minutes, because this is half of a revolution and when the passenger capsule is at its tallest point. Then I made a point at the height of 246 feet and 7.5 minutes, and another point at a height of 246 feet and a time of 22.5 minutes to mark when the passenger capsule is a quarter of the way done with a revolution and 3/4 of a way done with a revolution. Then I drew the graph and midline at 246 feet, and I found the amplitude by subtracting 246 from 443, which is 197. I found that the period of the graph is 30 because it takes 30 minutes to make one full revolution. I set 2 pi over b equal to 30. Then I cross-multiplied and divided to find that b equals pi over 15. I decided to make a negative cosine equation since the graph starts at the minimum. So the setup for my equation was y equals a cosine parentheses b parentheses x minus h parentheses plus k. I input 197 for the amplitude, pi over 15 for b, and there was no phase shift since the graph starts at time 0 and at its lowest height. I input 246 for the vertical shift, and I put a negative in front of the amplitude to flip the graph so it starts at its minimum instead of its maximum. After I made my equation and sketched my graph, I plotted the 5 original data points that I found onto Desmos. Then I input my equation onto Desmos, and once I found that my equation fit my 5 original data points, I dragged on the graph to find the remaining data points. And this is how I found the graph for the London Eye.